Hello everyone. This video is my project submission for the course on managing machine learning projects in Coursera. This project is about identifying an opportunity in a specific industry where machine learning can help to solve a particular problem, and it will be evaluated across multiple parameters such as the opportunity evaluation, the CRISP TM business understanding, the validation plan, the ML system design, and the potential risks in production. Right. So without further ado, let me directly jump into my solution. So in terms of the opportunity that I have selected, so the problem statement is like this, that recently RBI, Reserve Bank of India, which is the governing body or regulatory body for banks in India, has come up with a new rule which will be enforced in October, whereby users will be able to port their network service provider of the credit card that they are using. So if you, let's say if you have a Visa card or a MasterCard, users will have the option to change from Visa to MasterCard or vice versa, or to some other network service provider. Now this, and they will also enforce a rule whereby banks should not enter into an exclusive arrangement with a particular service provider, thereby having the scope to allow flexibility to customers to change the network service provider. Now this can lead to a intensification of competition between the different network service providers, because now customers will have more power in terms of choosing the network service provider that they want for their cards, right? So the network service providers should be concerned about tracking customer behavior, proactively identifying customers who are at risk of changing their network service provider, and hence taking active steps to retain those customers. So in this problem statement, we will only be focusing on identifying the customers who are at risk of churn. Now, why it's an attractive opportunity for machine learning? Because machine learning can actually help predict customer behavior, and it can help by analyzing the customer transaction history. It can actually help identify which set of customers are at risk to port to a different service provider. And because the volume of data would be huge, this is a task which cannot be done manually. So it has to be done in an automated way. And the reason why it's an important problem to solve is because a Visa, MasterCard, Amex, all of these different network service providers have millions and millions of customer base. So for them, losing customers to their competitor can actually lead to potentially millions of dollars of revenue loss per year. So that's why it's a big problem that the network service provider would like to solve for. Now, in terms of the problem statement, I think I just explained the problem statement. The problem statement here is to predict the credit card holding customers who are at risk of porting to a different network service provider. The target user of this model would actually be the key stakeholders within Visa, MasterCard, or any of the network service providers that are at play here. Why it matters? Again, it matters because customer churn can become a big issue for these network service providers. They earn a lot of revenues from these customers through the interchange income that they are generating through their transactions. So if they lose these customers, then that is a potential revenue loss for them. Now, currently, it's not a problem per se in the sense that RBI has not yet introduced this rule. So there is no solution that exists for this, because the problem itself is not yet present at the moment, meaning the customer cannot actually change their network service provider for now. Right now, the way network service providers try to keep customers into the ecosystem is by providing the same set of reward points to all the customers. Then there is no differentiation, and there is also no active way of identifying customers who are likely to, who are unhappy with their services or are likely to change. In terms of business impact, the business impact is simple. The task is for the network service providers to be able to retain customers and hence thereby save potential revenue loss. Constraints, again, I think the constraints kind of depends on the frequency of how frequency of how customer behavior change, but I think within 24 hours, every 24 hours, if the model can generate predictions of customers who are at risk with minimal cost of actually generating those predictions, then that would actually be the constraint over here. Outcome metrics, save potential revenue loss of maybe, let's say, USD $10 million a year. That's just a ballpark estimate. Output metrics should be that the model should accurately classify users into at risk or not at risk of churn. Now, what are the factors that can go into the model in terms of helping understand the churn behavior? So the factors could be spends, transactions, frequency of transactions, transaction type, whether they are making an online transaction versus transaction at a POS terminal, what category they are transacting at, how many reward points do they currently have, how frequently they redeem those reward points, etc. In terms of validating the solution, these are some of the approach that we can do is we can first identify the list of factors that can impact churn. This can be done by talking to the domain experts and getting their views. We can also actually talk to current customers of network service providers, understand their pain points, get their feedback, and try and understand what causes them to shift from, what might cause them to shift from one network service to another network service provider, how happy are they with their current service, network service provider, etc. Then once we have all this information available, we can also identify all the potentially relevant factors that can impact this churn or this portability, and can check if all the data points that we need to determine these relevant factors, whether these would be available or not. And basis that we can actually get a sign off from the key stakeholders of the network service provider, whether they can actually provide the required data points or not. After that, we can identify a couple of alternative approaches to develop the ML algorithm. We can list down the advantages and disadvantages of each, taking into account the cost considerations as well as whether the data considerations would be adequate for each of these models. We can benchmark the models against any heuristic method through which we might be able to identify this, and we can also see what kind of benefit we can actually get by deploying the ML model, and whether that benefit actually makes sense or whether we should continue using heuristic, right? So that way we can actually benchmark the performance improvements of ML algorithm. After that, we can create a couple of mock-up dashboards where this information about the churn and churn analysis would be fed into the relevant stakeholders within these network service providers. We can take these mock dashboards to those providers, to the key stakeholders within those providers, get their feedback, do a couple of iterations and fine-tune the dashboard in terms of what data points we are presenting, how frequently we are presenting it, etc. And then once all of this is done, we can finalize the dashboard and the model, and that could be a way of validating the solution. On the design consideration, there were 3 key points: cloud versus edge. So this can be a cloud-based solution because in this scenario, latency will not be a big concern. We don't need to provide real-time on-demand predictions. Customer behavior is unlikely to change every 5 minutes or 10 minutes. So latency will not be a big concern. Connectivity will be expected in this scenario, and the data, obviously, the training data will obviously be available on the cloud. In terms of offline versus online learning, it can be an offline learning mode because the customer behavior pattern is unlikely to change each day. The model can be retrained at predetermined intervals, and the model should be easy to train and it should be easy to evaluate, and that need for real-time adaptation is not present here. Batch versus online, it can be a batch prediction because customer behavior is unlikely to change each day. So even if we do predictions at regular intervals, that should be enough to solve the problem. In terms of potential risks in production, the training skew, this is unlikely to be a potential problem because the data that is there on production, we can easily replicate a mock data of that in the lower environments and train and test our models there. So this is not a big issue. Latency again is not a big concern here, but data drift and concept drift, yes, these two are possibilities that we need to take into account. User behavior, of course, can change over a course of time, so the model does need to be retrained at regular intervals to ensure it gives accurate predictions. Concept drift is more of a on a need basis. So if there are any significant shifts in the industry or the consumer behavior pattern or some external forces like COVID, so in those scenarios only the concept drift would come into the picture. But otherwise, it's not a huge risk. But yes, if there's some external factors that can have a significant impact on the consumer behavior, then we might need to retrain that model once that factor kicks in. That's it. Thank you.